Welcome to my channel. In this video, we are going to learn the basics of semiconductors. Now, in this video, I am going to cover these topics: why we need to study semiconductors, what are their advantages, what is the classification based on which, and then you have definition, I will define. Then we will discuss some properties of semiconductors and what are the categories. So, the basics of introduction to semiconductors. Now, let us see why. Semiconductors are responsible for the development of the technology and devices like modern day electronic devices, like we often use laptop, camera, cell phone, then washing machine, refrigerator. So, all these electronic modern devices, the semiconductors become the basic building block. Basic building block of those electronic circuits which form the hardware and the through devices like junctions formed by semiconductors like diodes and transistors, then integrated chips. So, semiconductors are important because they control the electric signals. Then what are the advantages which make them attractive for technological applications? They have low cost, they are reliable, and they have long lifespan. Power efficiency, which means there is no much loss of energy, and they are small in size, compact, and they can be operated at low applied voltages. So, these are the advantages that make them important materials. Now, let us see what are semiconductors, how are they classified. Classification of solids is made into three categories: conductors, semiconductors, insulators. So, conductors, they are also called as metals which have free electrons, and then insulators which do not have free electrons. So, they do not conduct electricity, current will not pass through insulators. Conductors, current passes through. Examples like copper, silver. Semiconductors, germanium and silicon. Then insulators, glass, diamond, etc. These are several examples. Now, on what basis this classification is done? Based on conductivity or resistivity. Metals have high conductivity, low resistivity, and insulators have low conductivity, high resistivity. They offer very high resistance, they cannot conduct electricity. Then the semiconductors are the materials which have moderate values of conductivity and resistivity. That means they fall in between these conductors and insulators. Now, let us see some of the values of resistivity for copper. For example, resistivity for copper, if I consider, it is 1.7 into 10 to the power of minus 8 ohm meter. Then for germanium, it is value is 0.6 ohm meter, and for glass the resistivity value is 9 into 10 to the power of 11 ohm meter. So, based on this you have the values, and you can see that the value lies in between these two. That means the resistivity of rho of semiconductor is greater than conductor, less than insulator. So, this value is less than the value of insulator, and this value is greater. So, this is less and this is more. So, there is another classification based on energy band diagrams. Now, valence band and conduction band, I will discuss about these energy bands in my next videos. So, if you consider metals, these two bands will overlap. So, this is overlapping in metals. Then there is a wide gap between them e.g. greater than 3 electron volts, e.g. the gap between the conduction band and valence band. So, e.g. is less than 3 electron volts, and for germanium it is 0.7 electron volts, and for silicon it is 1.1 electron volts. So, there is a wide gap, so large gap, so electrons from the valence band need that much of high energy to be able to reach the conduction band, and therefore conductivity is poor in insulators. So, it is neither a conductor nor an insulator, it is in between, so it is called semiconductor. So, let us define what is a semiconductor. Substances which have their resistivity ranging from 10 power minus 4 to 0.5 ohm meter, in between conductors and insulators. The value lies in between conductors and insulators. So, the range is in between. So, you have seen that for germanium it lies in between that of copper and glass. I showed you the example. Then what are the properties? So, resistivity is less than the insulator and greater than the conductor. So, the resistivity of semiconductors will always be less than insulator and greater than the conductor. Then another important property is this has a negative TCR. So, what is negative TCR? With increase of temperature, resistivity decreases. When resistivity decreases, conductivity increases. What is the relation between resistivity and conductivity? Resistivity is equal to 1 by sigma, or sigma is equal to 1 by rho, where sigma is electrical conductivity. So, that is negative TCR. Unlike in metals, with increase of temperature, conductivity decreases in metals. A suitable impurity added, that is doping, also increases the conductivity. I told you that we can control the electrical signals and control conductivity, and that is by increase of temperature or increase of impurity concentration. So, we will discuss them in detail later on. Now, there are two different categories. One is elemental, another one is compound. So, elemental semiconductors are examples like silicon, germanium, tin, which are 4th group elements, selenium, tellurium, which are 6th group elements. Compound semiconductors, compound means combination of two different or more than two different elements. So, these are different examples: gallium arsenide, indium phosphide, cadmium sulfide, cadmium selenium, etc. And these are most widely used for integrated chip IC applications, and these are used for light emission, light emitting diode, which you must be knowing. So, in the next video, I will discuss what are the different types of semiconductors and what is their structure, and mostly we will discuss silicon and germanium, which are most widely used semiconductors. Until then, keep watching, keep learning. Thank you.